When you're dealing with a titration, you know that you've reached the equivalence point when the moles of the acid are equal to the moles of the base that have been added. And all of the original acid that you started with has been neutralized by the base, and there's no acid and there's no base in that solution anymore. All you have is products. Okay, when this occurs, all the reactants have been completely used up. So again, you only have products. Okay, and typically you have a pH of around 7 or close to it. We'll talk about that. We've mentioned that a couple times, but we'll talk about that in a little bit more detail in one of the future videos. Okay, so one of the ways of determining the equivalence point is you can look at a pH curve and you just find the midpoint roughly of that vertical part of the curve, and then you go down, and that's where you know how much volume it took to get to the equivalence point. So one of the ways that you can determine the equivalence point of a solution or of a titration is to use what's called a pH meter. And it's something that you literally put into the solution, and it tells you, it's got a little screen, and it tells you what the pH of the solution is. And then you basically graph it all the way through. Okay, an easier way to determine the equivalence point, or very close to it, we'll talk about the difference here in a minute, is to use what's called an indicator. Okay, and an indicator is something that changes color from one pH to another. Okay, so an indicator is something that, for example, a very common one is called phenolphthalein. When it's in an acidic solution, it's clear, but when the solution turns basic, it turns pink, and it's really, really easy to see when that color change happens. Okay, because again, you go from one colorless solution to another. Indicators can be useful because, again, you're typically starting with an acid that has no color and a base that has no color. So those indicators are really, really nice because they do change color once you pass that equivalence point. So if you think about it, think about like a pH curve that looks like this. Until you reach here, that solution is going to be clear. So up till from about here to about right here might be just a very, very small amount. So you could twist that burette and let a little bit of the base out into the acid, and all of a sudden it goes from clear to a pretty solid pink color. Okay, and that tells you, oh, that's where I need to stop. Okay, now there are different indicators that can be used, okay, depending on what type of acid-base reaction you're doing. You might choose a different indicator. Okay, and again, this is kind of just the beginning of indicators. We're going to talk about indicators some more later on once we get into a little bit more details here. Okay, so for example, methyl orange is an indicator. You don't need to memorize this. They would give you a table. Okay, that when you are in the 5 to 6 range, and when it's an acid, it's red. And when it's in a base, it's yellow. So the solution will change from red to yellow. Okay, another one called methyl red, not methyl orange, is red and yellow, same thing, but it won't change until you're in the 6 to 7 range. Okay, litmus paper, which you can also use when it's in an acidic solution. That's the one you kind of just dip in there. And if it's acidic, it turns red. And if it's basic, it turns blue. And then phenolphthalein, the one I just mentioned, hard to spell, but it's a very, very common one, is colorless, but does turn pink. And that's the one you use most of the time when you're doing these in the laboratory setting. Now, the equivalence point, remember, is when those moles are equal to each other. Okay? And we want to choose an indicator where the change in color happens as close to the equivalence point as possible. Okay, but when the color change happens, that might not be exactly at the equivalence point, okay? That is what we call the end point, okay? They're basically the same thing, but they're not. Because if they ask you a question about the difference between them, they're not the same thing. The equivalence point is when the moles of the base that you've added are equal to the moles of the acid that you started with. The end point is when the color change happens. Okay, and again, you want that titration to be you want that end point to be as close to the equivalence point as possible. Okay, because like this drawing up here, if it doesn't change color until right here, let's say, does it really matter? Have you added? You probably haven't even added any more solution to go from this point here to this point here, that's probably just a very, very small amount. So many times the endpoint and the equivalence point end up being the same thing, unless you're talking about the difference between the two. Then again, the equivalence point is when the moles of the base equal the moles of the acid, and there's no reactants left, you only have products, whereas the endpoint is when the color change of the indicator happens. So here's just some different ones you can use. This one's a pretty common one. You start with a weak acid and you add a strong base to it, okay? And sometimes you have an acid that has more than one acidic hydrogen. So when that happens, let's zip ahead real quick to page 37. And then again, we're going to come back to this here in a little bit once we learn about this next section called buffers. Okay, here's buffers and titrations right here. So here you can see, like in H3PO4, you can see that you've got an equivalence point here, and then again, you've got your half equivalence point for that one. And then you've got another equivalence point where now you've lost that second hydrogen. And again, you've got another half equivalence point. And then you've got your third one as well to remove that third hydrogen. Notice that all hydrogens are gone, and there again is your third half equivalence point. Okay, so indicators can be really helpful, and they're really easy to use. Much easier to use than using a pH meter or something like that. Okay, and knowing which ones to use, again, typically they're pretty straightforward. Again, the key is you want the equivalence point to be as close to the end point, to where that color change happens, as you can be.